And in this video, we're going to continue our 8.3 notes. We've been talking about arithmetic sequences and series, and today we're going to talk about how we can find missing terms in these series. So if I give you the first term and the last term, we're going to be able to calculate all the terms in the middle. In order to do this, we're going to have to understand what the common difference is. So the common difference, that d variable we've been talking about, is the value that's been moved per term. So if I have a couple of terms from a sequence, I can calculate the common difference and then use it to find all of the missing terms. So we're going to go ahead and just jump in and take a look at some examples in order to figure out how to do this. So we're going to be looking at some examples, and in these examples, we're going to want to find the missing terms in the following arithmetic sequences. So these are the directions we're going to be following, and we're going to start with example A. We're going to take a look at this arithmetic sequence here in example A, and we're going to go ahead and calculate all of the terms in the middle of this sequence. So we have 11, and then a term, and another term, and then we end with the number -17. And I'd like to figure out what those three missing terms are from the center. So let's go ahead and take a look at how we can calculate that common difference. So remember, the common difference is the value moved per term. So all I have to figure out is the total value that we moved and then how many terms it took me to get there. So let's start with the total value moved. In order to figure out the total value that we've moved, all we have to do is take the last term and subtract the first term. And that'll tell us the total distance between those two terms. So my last term is the number -17, and my first term is the number 11, so I'll subtract 11, and the total value that we've moved is -28 spaces. So we started at +11 and we subtracted a total of 28 to be able to reach the number -17. So that's the total value moved. Now, the common difference is the total value moved per term. So the next thing we have to figure out is the terms it took us to reach that. So terms until we reached the last. And that just means how many times did we move? So the times we moved. And it's really important to understand it's the times we moved, not the total number of terms in the problem. I want to figure out the difference, so I need to figure out how far I moved from where I started. So if we take a look at this, this would be one time we moved, one common difference. This would be a second common difference. This would be a third common difference, and then we move one more time here, a fourth common difference. So we're basically just asking how many times we moved, and in this case, we moved 4 times. We moved once to get from 11 to the next term, and then again, and one final time to get to that -17. So we moved a total of 4 times. Once we know the total value we moved, and then the number of terms it took us to get to that place, we can calculate d. So d is the common difference. And remember, it's just the, it's the value moved. Value moved per term. Remember, the word per just means divided by, so the value moved divided by the number of terms it took us to get there. So that means all I have to do is plug in those two numbers that I just calculated. The value we moved is -28. The terms it took us to get there were 4, so my common difference is just going to be -28 divided by 4, which is -7. So that tells me d. d is -7. And I can use the value for d. I must have moved 7 spaces in the negative direction each time. I can go ahead and use that to find my answer. So I'm going to go ahead and rewrite my answer. My answer started with 11, and then we had a missing term. And all I have to do to find that is subtract 7. So if I do 11 minus 7, the next term is 4. Then I had another missing term. I must have subtracted 7 again. That would bring me to -3. Then I had another missing term. I must have subtracted 7 again, and that would bring me to -10. And the last jump should have taken me to the final number that we had in the original, which was negative 17. It wasn't a blank, it was just a number, negative 17. And we can see, just to check, that if I do one more jump of negative 7, that it does in fact take me to the number negative 17. So I found all three missing terms from the center. I went to 4, then negative 3, then negative 10, and finally made it to negative 17. Let's go ahead and try that again. Let's do another example of this. This time our sequence is going to start with 2, and then I have 1, 2, 3, 4 blanks, and then I have the number 42. So again, we're going to want to calculate the common difference, which is the value moved per term. So let's calculate the total value moved first. Remember, the value moved is going to be the last term, 42, minus the first term, 2. So this time the total value moved is 40 spaces, and I went in the positive direction, so my numerator is going to be 40 and it's going to be positive. Then all we have to do is count the number of terms. So how many jumps did it take for me to get there? So I move 1, 2, 3, 4, 5 spaces. So it took me 5 jumps to get to the final number. So our common difference is just 40 divided by 5, which is a positive 8. So I must have added 8 between each term. So I can go ahead and fill in all of my missing terms using that information. To get from 2 to the next term, I must have added 8. So that gives me, that should be a plus 8. That gives me 10. And then another plus 8, the next missing term is 18. Another plus 8, the next missing term is going to be 26. That's a 20. There we go. Then we add 8 again. We must have gotten to 34. And then one final plus 8 gets me to the number 42. So we found all the missing terms in the middle. All we have to do is figure out the value moved and then the number of terms it took me to get there, which was the number 5. And divide those, and we're done. All right, let's go ahead and have you try a couple. So what I'd like you to do is please pause the video and try these 2 examples, and then I want you to resume the video when you're done so that you can check your work. It should be pretty straightforward. Remember just to find the total value moved, and then find the number of terms it took to get there, and then come and check your work with me when you're done. All right, so you should have paused the video and worked on these 2 problems. Let's go ahead and check your work. So we're going to go ahead and try C. For example, C, in order to find our common difference, all we have to do is find the value moved, which should have been the last term, 18, minus the first term, 3. So our numerator here would have been 18 minus 3, which is 15. And the denominator is going to be the total jumps it took to get there. So 1, 2, 3 jumps. So we would have been dividing by 3. So our common difference is just 15 divided by 3, which is the number 5. So we must have added 5 each jump. So if we add 5 to 3, we get 8. If we add 5 again, we get 13. And then one final plus 5 brings us to the 18. So we found the 2 missing terms in the middle. Let's go ahead and try that again for example 4. So to find my common difference, I have to find the total value moved, which in this case is negative 8 minus 4. So that numerator would be negative 12. And then we have to find the total jumps it took to get there. So 1, 2, 3, 4, 5, 6 jumps. So we're going to be dividing by 6. So in this case, my common difference is negative 12 over 6. So we must have subtracted 2 each time we moved. So all I have to do to fill in my missing terms is just subtract 2 in each jump. So 4 would go minus 2 to 2. Subtract 2 again, we get 0. Then negative 2. Then negative 4, then negative 6, and we end up at negative 8 by subtracting 2 one last time. All right, so pretty straightforward trying to find those missing terms when we have the first and the last. We do have one more situation where we would have to find a missing term, except this time we don't have a first term. So I'm going to give you the directions to do that. If we need to find a missing term with no first term, go ahead and write down these steps. Pause the video if you need to finish writing them down. If we don't have the first term, we're going to have to write, unfortunately, we're going to have to make a system of equations to help us. So we're going to do step 1. We're going to use the information given in the problem to write 2 equations. They're going to have to give you 2 terms, so we're going to use the information for those 2 terms to write 2 equations. Once we have the 2 equations, we're going to have to solve for the common difference, D, using elimination. So if you recall back to where we were studying systems of equations, elimination is where you subtract your equations. Our third step is going to be to use that common difference to solve for a sub 0, and that's going to be where we have to take the common difference and plug it back in to either one of the equations we created in step 1 to find that other piece of missing information. And last but not least, we're going to have to use the common difference in a sub 0 that we found to write our general equations so that we can solve our problem. So before we can actually solve the problem, we're going to have to go and find our two missing pieces of information, a sub 0 and the common difference. And we're going to use the system of equations to do that. So let's go ahead and take a peek at this type of problem. And we're going to do that over here. I have mislabeled my examples. I just realized this should be example E, because we just did A, B, C, and D. So this is example E. We're going to find the 6th term in this arithmetic sequence. And this time they've given us a sub 9, which equals 120, and they've given us a sub 14, which is 195. So let's go ahead and take a look at how we can do step 1. Step 1 is going to be to go ahead and write our equations. So write two equations. We know the general form for our equations, the one that we use, is a sub n equals dn, common difference times the term number, plus a sub 0. So let's go ahead and take a look at what we've been given. Now, in this first equation, a sub 9 equals 120. Remember, whatever number is down here, that's the nth term. So this is the 9th term. And then over here, 120, that's a of n, so a sub 9. And again, in this equation, we have something similar. This is the 14th term, n, and this is a sub 14, so that's a of n. So we've been given two pieces of information that we can write general equations for using our information. So let's go ahead and try to do step 1. We've been given a sub 9 equals 120. So the equation we can write from that is 120, this is our a sub n term in front, 120, equals the common difference times the term number, and I've been given the term number, this is the 9th term. And then we're going to add a sub 0. I don't know what a sub 0 is. So I plugged in that n9 into my equation, and I know a sub n is the number 120. So I used the equation in green and filled in a sub n and n based on my equation in red. Now let's go ahead and do that again for a sub 14. So for a sub 14 equals 195, we're going to go ahead and create the equation 195 equals the common difference times the term number, which in this case is 14, and then we're going to add a sub 0 to the end. So here are our two equations. That was step 1. Now for step 2, we're going to have to use the process of elimination. So step 2 is elimination. And if you remember, elimination just means subtract your equations. So I'm going to take this second equation here, and I'm going to subtract it from the one above. Now we're going to have to subtract the entire equation. So I'm going to change every single sign to the opposite sign so that I can subtract all three terms from the ones above. This is my elimination step. So 120 minus 195 gives me negative 75. This d times 9 is just 9d. And then d times 14 is just 14d. So if I take 9d and subtract 14d, I end up with negative 5d. And then if I start with a sub 0 and subtract a sub 0, it doesn't even matter that I don't know what that number is. I will end up with nothing. When I subtract something from itself, I get 0. So that term goes away. My a sub 0s cancel. So plus or minus nothing. That term is gone. That's why we're using elimination. It removes a sub 0 from the equation, and it allows me to solve for d. So that's what we're doing here. Solve for d. So all I have to do to finish up this step is just get d completely alone. We'll divide by negative 5 on both sides, and we will get d equals that negative 75 divided by negative 5, which is going to be positive 15. So we have used elimination to solve for D. That was step 2. Now we're ready for step 3. Step 3 says that we need to use the D we just found to find a sub 0. And in order to do that, all I have to do is plug D back into either one of my original equations. It doesn't matter which one I use. I'm going to use the first one I created. I'm going to go ahead and use 120 equals D times N. Oh, sorry, not N. I knew what N was. N was the number 9. D times 9 plus a sub 0, except now I know what D is. So right here where I've got D, I'm going to plug in the number 15. So that means I'm going to have 120 equals 15 times 9 plus a sub 0. And I'm going to be able to go ahead and solve for a sub 0 because now it's the only piece of missing information in this problem. So let's go ahead and do that. So 120 is going to equal 15 times 9. 15 times 9 is 135, and then we have to add a sub 0. We want to get a sub 0 alone though, so we're going to go ahead and subtract 135 from both sides, minus 135, and we end up with this a sub 0 on its own on the right, and on the left we end up with the number negative 15. So it looks like our very first term was the number negative 15. Now we're ready for our last step. We found D and we found a sub 0, so we're ready to go ahead and find our formula. So our formula, remember, is that a sub n equals dn plus a sub 0. So we know that a sub n is going to equal d times n. D is the number 15 times n. And then we add the number a sub 0. A sub 0 is negative 15, so we subtract 15 from the end here. So that's our general equation. We plugged in the d we found before, 15, and then we just plugged in our a sub 0 as well, the negative 15 at the end. Now we can find any value in this sequence. And my original problem, if we go back and check, my original problem wanted us to find the the sixth term. So we're going to use the equation we just wrote and plug in the number 6 for n. So let's go ahead and do that. We're ready to find our final answer. So a sub 6 is going to be 15 times 6 minus 15, which is going to be 90 minus 15, which is the number 75. So a sub 6 is 75. It does take a little bit of work to get to our answer. We do have to go and find 2 missing variables before we can even start to solve the question that was given. But using systems of equations, we can find any missing term. All we have to do is make sure we calculate the common difference and then the original term. So let's go ahead and try one more example. Here's our last example. This is example F. Okay, so we are going to find the 11th term of this arithmetic sequence. The third term is 20, a sub 3 equals 20, and a sub 10 equals the number 8. So let's go ahead and do our 4 steps in order to figure out what the answer is here. We're going to start by writing 2 equations. So step 1, write 2 equations. We're going to use a sub 3 equals 20 to write our first equation. So a sub n, 20, equals d times n, which is the third term, and then plus a sub 0, which I don't know. And then we'll write our second equation, a sub 8 equals 10. We know that a sub n is 10 this time, and it's d times n, whatever that n term is, which in this case is the number 8, plus a sub 0. So here are our 2 equations. Now we're ready for our second step. We're going to use elimination. We'll subtract the 2 equations. So we'll subtract every single term. 20 minus 10 is just 10. If I take 3 d's and subtract 8 d's, I end up with negative 5d. And my a sub 0's will cancel each other out again. So plus or minus nothing. That part is gone. So that's it for my second step. Oh, just kidding. I have to finish solving for d. We'll divide both sides by negative 5, and then my second step will be done. So d is going to equal, and this is finding d, 10 divided by negative 5, which is negative 2. So here's our d value for this problem. D is negative 2. Step 3, we'll use that d to find a sub 0. So let's go ahead and find a sub 0. So I'll take the number -2 and plug it into either one of my original equations. It doesn't matter which one I use. I'm going to go ahead and use the first one because I feel like it. So we're going to use the equation 20 equals d, which is -2, times n, which this, for the number 20, it was the number 3, and then plus a sub 0. So now all I have to do is solve for a sub 0. So -2 times 3 is -6, plus a sub 0 equals 20, and then I just add 6 to both sides. So that means a sub 0 is going to be the number 26. So I found d and I found a sub 0. Now I'm ready to write my general equation so that I can solve for anything. So here we are, making a mess. Here we are in step 4, ready to write my general equation. Remember the format for that is a sub n equals dn plus a sub 0. So a sub n is going to equal dn. D was the number -2. -2 times n plus a sub 0, which is the number 26. So dn plus a sub 0 plus 26. Now we can solve for anything, and if we just go back and double check, the number they wanted us to solve for was the 11th term. So let's go ahead and find the 11th term. We're going to plug in the number 11 for n, here and here. So a sub 11 is -2 times 11 plus 26. So -2 times 11 is -22. We just have to add 26, and we get the number 4. So a sub 11 equals 4. And that's it for this process. Now that you're finished with your notes for this video, go ahead and take a look at the homework assignment that's going to be due later on this week.